Hey there! In this very short but important video, we're going to go over something called recursive formulas or recursive sequences. So recursion is the way that we naturally understand sequences. For instance, when you were born, you weren't born to understand sequences like we've gone over in the past with functions, right? Where we look at the patterns that way. We look at the patterns like normally. We look at something, we say, oh, that number system goes up by 1 every time. 1, 2, 3, 4, and the next one would be 5, and then 6 because we're going up by ones. Or 2, 4, 6, 8. We add 2 to every term to get the next one. These are the ways that we naturally understand sequences. This comes up a lot in actually computer science and in engineering, especially of computer programs. But I'm not a big coder, so I won't dive into that too much. But recursion is very, very cool, and it means to recur. So just in case your teacher or professor goes over this, here it is for you. It's not on the BC exam, but you might have a professor or teacher that expects you to know it. So here you go. This one's for you. We are given this formula here, and the instructions say use the recursion formula to write the first 4 terms of each sequence. So this says a sub n plus 1 equals 3an plus 4. What that means is the next term, the n plus first term, is equal to 3 times the previous term plus 4. So the next term would be, and we want the first 4 terms, so we've got a sub 1 is equal to 2. So a sub 2 would be 3 times this term, 3 times 2, plus 4, which is equal to 6 plus 4 is 10. And then a sub 3 would be the next term, and we take 3 times this term and add 4. So that'd be 3 times 10 plus 4, and that would be 34. The next term after that, a sub 4, well, that's going to end up being 3 times what we got the last time. So 3 times 34 plus 4. 3 times 34, let's see, is 102 plus 4 is equal to 106. Not bad. Then all we've got to recognize too is that we could, well, that's your answer. Those are the first 4 terms of each sequence. So it'd be 2, 10, 34, and 106. So that's recursion, where you're using the previous term or previous terms to find the next one. You could also have looked at it this way and said a sub 2 is equal to 3 times a sub 1 plus 4, and then plugged in, right? And then a sub 3 or a sub 2 plus 1, which would be a sub 3, is equal to 3 times a sub 2 plus 4. You could look at it as plugging in numbers, that's fine. I like to look at it as the next term is equal to 3 times the current term plus 4. Okay, in the same idea, in this one, we've got the first 2 terms, so we only need to find 2 more. A sub 1 is 1, a sub 2 is 3. This tells you the term we want is equal to 1 term ago, n minus 1, plus 2 times 2 terms ago. So a sub 3 would be equal to 1 term ago would be 3, right? That'd be a sub 2, plus 2 times 2 terms ago, which would be 2 times 1. And so that's equal to 5. And then to get the 4th term, that would be, well, now 1 term ago is going to be now 5, plus 2 times 2 terms ago, which is now 3. And that's 2 times 2 terms ago, 2 times 3, and that simplifies to 11. And you could keep going on and on like that. So the sequence is 1, 3, 5, 11, and we could keep going. Now in this one, it might be easier for some people to have calculated a sub 3 by saying a sub 3 is equal to a sub 3 minus 1 plus 2 times a sub 3 minus 2, almost using this like it's a function and plugging in numbers. And then that would have been a sub 2 plus 2 a sub 1. And then you understand, okay, I take a sub 1, plug it in here, a sub 2, plug it in there. That's fine if you do it that way. I think it's easier to just understand it as 1 term ago plus 2 times 2 terms ago. That's it. That's recursion. Just wanted to do a real quick video on that one in case you're asked to be able to evaluate these things. They're not that bad, but they sometimes come up in Calc 2. I will see you in the next video. Peace.